Okay, let's take a look at this number 4 now. This is the problem number 4. We want to find the Maclaurin series for this guy. This is really nice guy, right? So let's experience it. So I'm gonna follow my the definition again. So the Maclaurin series means x is equal to 0. So therefore I need to find f prime, which is 5 times 2 plus x raised to power 4. F double prime, which is 5 times 4 times 2 plus x raised to power 3. Third derivative, and then second derivative, right? I mean fourth derivative, right? Fourth derivative is 5, actually 5 times 4 times 3 times 2 plus x. And then the fifth derivative, I'm running out of room here, so I'm going to write the fifth derivative here. It's going to be 5 times 4 times 3 times 2 times 1, because 2 plus x, the derivative is just 1, which is 5 factorial. And sixth derivative, well, this is a constant already, so sixth derivative will be 0, therefore the seventh derivative, then eighth derivative will be all 0. So with that, let's do the use the Taylor series definition. Let's write this. 2 plus x raised to power 5 equals, so f of a, well, better to write my f of a down. A is 0. So f of 0 is actually 2 to the power 5. F prime of 0 is going to be 5 times 2 to the power 4. F second derivative at 0 is going to be 5 times 4 times 2 cubed, and so on and so forth. Okay, 4 times 3 times 2 square. And the fourth derivative at 0 is going to be, so this is fourth derivative. It will be 5 times 4 times 3 times 2 times 2. And the fifth derivative at 0 certainly is just 5 factorial. So with that, and actually my, so the first term will be 2 to the power 5th. Second term will be f prime of 0, which is 5 times 2 to the power 4. And then times x raised to power 1, right? The next term will be here, 5 times 4 times 2 cubed over 2 factorial x squared. The next one will be 5 times 4 times 3 times 2 squared over 3 factorial x cubed. And the next term is 5 times 4 times 3 times 2 times 2 over 4 factorial x to the power 4. The next one is actually 5 factorial over 5 factorial x to the power 5th. All the other ones are 0 because all these derivatives are 0. If you simplify it, 2 to the 5th is 32. 5 times, this is 16, which is 80. Okay. The next one is actually, if you do the algebra, 80x squared. The next one is 40x cubed. The next one is actually 10x to the 4th. The very last one is x to the 5th. So this actually is the Taylor polynomial for this particular function. So I would like to challenge you to expand this by hand. 2 plus x raised to power 5, expand it. You will see actually it is this guy. Okay, so basically it's Taylor polynomial is Taylor series. It's just its expansion. So it's identical. Now, more interestingly, I would actually like to, I don't want to go through this in my video now. I actually want you to get a chance to do the next problem, find the Taylor polynomial. Okay, find the Taylor polynomial. Allow me to keep it as a secret for now so that you can challenge yourself to do so. Just follow the definition and you'll be surprised on what you'll find. Okay, and also find the Taylor series for f at a equals 1, I think it is also pretty straightforward because these are all these terms are easy to compute to get the derivative. Okay, so this is it for this particular problem number 4.